Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about graph theory. So before going to see that, so what is a cosine wedge problem? So Kosenberg is a city on the Trigal River in Persia. The city is going to be occupied by two islands plus areas of both banks. So the problem is that whether they could leave home or cross every bridge exactly once and return home. So for this problem, how are we going to solve it? So that is the problem. So actually, this Kosenberg bridge problem is that the cities is going to be occupied by two islands and at the same time plus areas on both banks. So the problem is to have that they could leave home, so cross every bridge exactly, and then have to be returned to home. So for that, the model is going to be defined like and vertex should be considered as island, and edge is nothing but a path, or it may be a bridge between the two islands. So okay, so the vertex, so these are the cities, what we call as islands, and the both the islands. So the path, the bridge is there in between the cities, right? So this bridge, so nothing but a path between the two islands. So in generic model, so the vertex is nothing but an object, and edge is nothing but the relationship between the two objects. Okay, so there should be a one member and another should be another county where they should be joined by an edge here. So the vertex is an object and the relationship between the two objects. So what is a graph here? So graph is nothing but ordered pair v comma e consisting of vertex set w x y z and edge set e1 e2 e3 e4 e5 e6 and then e7. So the graph is nothing but an ordered file consisting of a vertex set and then edge set. So the vertex set is nothing but w, x, y, z, and the edges will be e1, e2, e3, e4, e5, e6, and then e7. So a graph is an ordered triple consisting of V is nothing but set of nodes, points, and vertices, and E is nothing but a set, so whose elements are known as edges and lines. So if F is the function, so that maps each every element of E to an unordered pair of vertices in V. So graph is an ordered triple, so which should be consists of set of nodes, points, or vertices, what we called as. So vertices, I can able to call it as nodes, or I can able to call it as points. And E is nothing but elements, so we should be represented as edges, or I can able to write it as lines. And F is nothing but a function, so that maps each element to the unordered pair of the vertices. So next one is loop. So loop is nothing but edge whose endpoints are equal and multiple edges have the same pair of endpoints. So the loop is nothing but an edge whose endpoints are equal, and the multiple edges means the edges that should is going to be shared the common pair of endpoints, like multiple edges and loops. So here if I'm going to have a vertex here, so this should be called as an edge. Similarly, if I'm going to consider another edge, then we should be treated as multiple edges of the vertices. So what is this simple graph? A graph that has no loops or multiple edges is nothing but a simple graph. So a graph does not have any kind of multiple edges in between the vertices, So then I can able to treat it as a simple graph. So whenever there is exists a multiple edges between the two vertices, so then there should be not be a simple graph here. Okay. So similarly, if I'm going to have an edge through the self-directed edge, so self-directed vertex, then this should be called as a loop here. So graph is nothing but does not have any loops or multiple edges. So in simple graph is nothing but a graph which is going to have same edges. So that should be a simple graph, and a graph that is going to have multiple pairs is called multiple edges. Adjacent and neighbors. So the two vertices are nothing but adjacent and or neighbors if they are endpoints of an edge. Okay, so the two vertices are said to be adjacent if there exists an edge between the two vertices. So A adjacent vertices. What are adjacent vertices of A and B should be B and then C. So A and B are adjacent, but there is not an edge between A and B. So that's why they should not be treated as adjacent vertices. So A and D are not adjacent. So AB are adjacent, AC are adjacent, BC and BD are adjacent. So these are all will be adjacent vertices or neighbor vertices. So the two vertices are nothing but adjacent or neighbors if there exists an endpoints of an edge. So next one is that finite graph or null graph. So finite graph means a graph whose vertex and edge are finite. A null graph means the graph whose vertex set or should to be empty. So the finite graph is a graph so whose vertex set or finite set should be empty here. So vertex set, so V should be set of vertices and E should be the set of edges E1, E2 and E2, E3 set of edges is like this. So this should be called as a finite graph. A graph which does not have any kind of vertices and edges which are empty, that should be treated as a null graph. Next one, connected and disconnected. So the connected means so there exists at least one path between the two vertices, and disconnected means otherwise. So that means H1 and H2 are connected, okay, and H3 is disconnected. So because there should not be exist any path between the two graphs, right? So that's why it should be called as disconnected. So here each there exists edge between every pair of vertices, so that's why it should be connected one, and H2. So there is a edge between the one vertex and the vertex, and each and every vertex are fully connected. So H2 is also connected. But in comes to H3, so there should not be any edge between A to B and then A to D and E to D and A to B like this. So that's why it not be a fully connected, what we call it as disconnected graph, and this one should be connected graph. So what is a complete graph? A simple graph in which every pair of vertices are adjacent, so that should be a complete graph. So if the number of vertices is n, there are n minus 1 edges. So a simple graph is the graph in which every pair of vertices are adjacent here. If the number of adjacent equal to n, there are n1 to n minus 1 edges here. So this is a graph, trivial graph, and this is also a graph, and 3 vertex graph, and 4 vertex graph, then 5 vertex graph, and 6 vertex, 7, and then 8 vertex. So the complete graph. So there is an edge between for every pair of vertices here. So this should be called as a complete graph. A graph in which every pair of vertices are adjacent, then it should be called as a complete graph. If the number of vertices is n, there are n to n minus 1 edges. Sparse and dense graph. What is a sparse and dense graph? A graph is said to be sparse where the mod of E should be equal to mod of E, and where the graph is said to be dense if and only if the mod of E should be equal to mod of V square. And next one is directed graph. So in a graph, if there is edges are going to be have a direction, then it should be treated as a directed graph. So this is the undirected graph. Since I'm not mentioning any kind of vertices, any kind of directions. So if I'm going to mention a direction like this, so then it should be called as a directed graph. I'm able to call it as digraph. So in digraph, the edges is going to have directions, whereas in undirected graph, they should not have any kind of directions here. And next one is weighted graph. So weighted graph is the graph for which each edge has an associated weight. So usually given by weight function. So that should be represented by W is equal to E tends to R. So here, so this is the graph. So for every edge, they are going to have an edges. Each and edge is going to have weights. So this one would call it as weighted graph. So the graph which does not have any kind of weighted, that should be unweighted graph. So the weighted graph is the graph from which each edge is going to have associated weight, usually given by the weight function should be W is equal to E tends to R. And next one is planar graph. So what is a planar graph? So the graph which is going to be drawn on a plane such that no edges, two edges should be intersect. So that should be called as a planar graph. Suppose in this graph, so what will happen? So these two edges are intersect each other. So that's why this should not be not a planar graph. So in this one, the no two edges that coincide with each other. So this should be called as a planar graph. So the graph which is going to be drawn in a plane where the edges does not intersect each other. So this one called as a planar graph. And next one is complement of G. So what is the complement of G dash? Uh, so the complement means the complement of a graph is nothing but a simple graph. So where uh, the vertex and the edges of the complement is quite opposite of the normal graph vertex and normal graph edges. So if there is a vertex here, and the quite opposite of this will be considered as vertex, and the edges means, so UV is the edge of the graph. So then the UV where it does not belongs to edges of the graph should be considered as a complement of the graph. Suppose here U, V, W, X, Y, Z are the vertices. So it should be similar to the uh, vertex of the graph as well as vertex of the G complement graph. And the edges, when it comes to edges, so there should not be an X from U to W and then Y to V and X to V and Y to W. So these edges are missing here. So this one and this one and this one and this one. So the edges what I drawn just now, these edges are misses, right? So all these edges are going to be reflected into complement of the graph here. And next one is subgraph. So subgraph of a graph is nothing but, so V of H is subset of V of G and E of H should be subset of E of G. So the assignment of the endpoints for edges in H it should be the same as G here. The subgraph of a graph is a graph such that V of H should be the subset of V of G and E of H should be the subset of E of G. So this is the graph. So what is the subgraph of this graph G? So I can able to draw A, B, D. So this is the subgraph. Also I can able to draw A, B, C. This is also under subgraph, and B, D, C. This is also under subgraph. So like this, you can able to draw so many subgraph of the given graph. So see here the example. So this is the given graph. So G. So A C2D. So C2D means, so this is the one of the subgraph. So that means this, and AB ED. So AB and ED. So this is the under subgraph, and H3 also a subgraph. And next one is what is biparty graphs. So graph is said to be biparty if V of G should be the union of two disjoint sets called parted sets of G. So also these vertices can be partitioned into two sets such that each set is independent. So that should be example one of that is matching problem and job assignment problem. So the graph is said to be biparty graph. So if and only if the vertex of the G should be the union of two disjoint independent sets. So the vertices can be partitioned into two sets such that each set is independent. So what is the matching problem and job assignment problem? So is one of the example of that. So matching and then job assignment. So these are the workers here. So these workers is going to be do what kind of jobs here. And next one is chromatic number. So the chromatic number of graph G can be written as the minimum number of colors that are needed to label the vertices such that the adjacent vertices receive the different colors. Okay, so the chromatic number of graph is written as x of G. So it should be called as minimum number of colors needed to label the vertices so that the adjacent vertices receive the different colors. So if I'm going to draw, so if the vertex is going to be drawn with blue color, so this is the red and this is the green. So this, if I'm going to take red here, again the two vertices are going to be equal. And again, if I'm going to green here, so again, so I can able to take yellow, but I have an option. So if I'm going to draw blue here, so what will happen? The node two adjacents are equal. So then the chromatic number of the graph should be written as 3. This is the minimum. So the chromatic number of the graph should be written as x of G. So it should be nothing but the minimum number of colors that are needed to label the vertices, such that no two vertices receive the different colors. Maps and coloring. So what is a map here? So map is nothing but a partition of the plane into two connected regions. So we can able to color the regions of every map using four most colors as that the neighbor regions does not have different colors. So the map coloring implies is nothing but graph coloring. So the a region should be considered as a vertex and adjacency should be considered as an edge here. So the map coloring, so the map is going to be partitioned into different planes. So right, so where the each region should be considered as a vertex, and so I'm going to take R1, R2, R3, and R4. So this is the region where I can able to shade with blue, and this is the region where I can able to shade with different color, and this is the region where I can able to shade it. So if I'm going to consider this should be considered at a separate one so that the no two colors is going to have that. And next one is scheduling and graph coloring. The two committees cannot hold the meetings at the same time. So if the two committees have the same common number, so that should be considered as scheduling of that one. So the graph coloring is something different where you can should be able to color the graphs in such a way that so that no two colors is going to be adjacent to each other. And next one, what is the model we are going to have? So suppose if the one committee is going to be represented by vertex, so the edge between the two vertices, if two corresponding vertices have the common number and two adjacent vertices cannot receive the same color, then it should be considered as graph coloring. Scheduling and graph coloring. Scheduling problem is almost all equal to the graph coloring. So here the vertices are going to be colored with different numbers in such a way that the no two vertices is going to be a same here. And that means the same color and time slot should also be not same. And next one is the degree. So what is this degree? So degree of the edges is nothing but the number of edges that is incident on the node should be considered as degree. So if I'm going to consider vertex A, so the two edges are incident on this. So this is the degree of 2 and this is also degree of 2 and here also degree of 2 and for this degree is 0 and for this degree is 1. So if I'm going to consider a direct edge, so what is the degree of A? So the degree of A equal to 2 here. And for B, the degree should be 1. And for C, degree is 2. And D, degree is 0. So in A, and 2 edges are leaving, so that's what degree is 2. For B also, only 1 edge. So for C, and 2 edges are leaving, so that should be 2. So normally the degrees is nothing but the number of edges incident on the node should be considered as the degree here. For suppose normally the degrees is going to be calculated into two categories. So first one is in degree and second one is out degree. So in degree means the number of vertices that are incident to vertex should be treated as in degree and the number of edges that are leaving from the vertex should be considered as out degree. So this is the degree in case of directed graph. So the in degree means the number of edges entering the node and out degree the number of edges leaving the node. So the total degree should be considered as in degree plus out degree. So in this figure, so what is the in degree for the vertex I'm taking and then in degree, out degree and total degree. So the vertex one, what is the in degree here? So only one index, one incoming edge. So that's why I'm considered as one. And out degree is only one edge that is leaving. And for two, I'm going to consider. So in degree is two, out degree is one. So out degree is also two. But this is one, this is one. And for five, so in degree there is only one edge is coming. Two edges is coming. So two and one edges is leaving. For in degree of 2, 2 and 2. And for 4, in degree is 2, out degree is 2. So the total degree of vertex is 2, 4, 3 and then 4. So like this we are going to calculate the degree of all the vertices, which should be the sum of in degree plus out degree here. So degree in simple facts. So G is the directed graph with m edges. Then in degree of V should be considered as our degree of V. So if the graph is going to have n edges, then the degree of V should be considered as 2m here. So the number of out degree nodes should be considered as even. And next one, what is a path? So path is nothing but a sequence of vertices such that there is an edge from each vertex to its successor. So a path is said to be simple if each vertex is distinct, and circuit is a path which the terminal vertex coincide with the initial vertex. So the path or edge is nothing but so the sequence of vertices. So the sequence of vertices such that there is an edge from vertex to its successor is nothing but a path here. So this is the path. So V1, V2, V3, V4 and V5. So the path can be written as V1 to V2, V2 to V3, V4 to V5. Okay, and circuit is nothing but it should be the closed one. So where the starting and then ending vertex should be same. So the path is here is V1, V1 to V2, V2 to V3, V2 to V4, again V. So that means the source and destination of vertices should be same here. So then it should be considered as circuit, and this should be the path here. And next one, what is a cycle? So a path from vertex to itself is nothing but a cycle. A graph is said to be cyclic if it contains a cycle. So that means, so a path from vertex to itself is nothing but a cycle. A path from vertex to itself is nothing but a cycle. A graph which is going to have this kind of cycles, so then it should be considered as cyclic graph. And the graph which does not contain any kind of cycles then should be considered as a cyclic graph. So V1, V2, V3, V4 and V5. So this graph does not have any kind of cycle. So this should be considered as a cyclic graph. So in this one, so there should be a closed loop here. So this one, so this one should be considered as a cyclic graph. And this is also going to have cycle. So what are the different types of paths here? So shortest path. So geodesic paths are not necessarily unique one. It is quite possible to have more than one path of equal length between the given pair of vertices. And Euclidean path or Euler's path, what we call it as this. So the path that travels from each edge in the network only once is considered as Euclidean path. So the traversing the each edge in the graph only once should be considered as Euler path, and then visiting each vertex in the network only once is nothing but Hamiltonian path. So if I'm going to visit the edges only once in the graph, that thing should be considered as Euler path. And if I'm going to be considered only the vertices which is going to visit only once, that should be considered as Hamiltonian path. So what is Euler path? So Euler path, so undirected graph which possesses an Euler path if and only if it is connected and has either 0 or 2 vertices of odd degree, or otherwise I can able to say that the undirected graph possesses Euler path if and only if it is connected and its vertices all are having even degree. So that is nothing but Euler path. So the Euclidean path is nothing but an undirected graph which is going to possess Euclidean path if and only if the connected is going to have 0 or 2 vertices of degree. Otherwise, if if its vertices all are having even degree, then it should be considered as Euclidean path. So there is no Euclidean path for the cosine bridge problem. So that should be about the graph theory. So here in this video I discussed the basic terms that is going to be used in the graph. So the graph is nothing but a order triple, so consisting of vertices and edges, and the loop is nothing but the edge whose endpoints are equal, and multiple edges means the edges that is going to have the same pair of endpoints. And some types of graphs here. So simple graph, a graph which does not have any kind of loops and edges, multiple edges, we call it as a simple graph. And the two vertices are going to be said to be adjacent if there is this edge between and the two vertices. And what is the finite graph and null graph? A graph whose vertex and edge set are finite, that should be considered as finite, and a graph whose vertex and then edge set are empty, that should be considered as null graph. So how we're going to say that connected and disconnected means. So if there is a edge between for every pair of vertices in the graph, then it should be considered as connected graph. And if there is no edge in between the two vertices, that should be considered as disconnected graph. So the complete graph means for every pair of vertices in the graph, there should be an edge between them. The sparse and dense graph means where the mod of edges is equal to mod of v, then it should be considered as sparse graph. And the graph is said to be dense if and only if the edges mod v is equal to the square of that vertices. So the graph which is going to have direction, that should be considered as directed graph, and the graph whose edges having weights, then it should be considered as weighted graph. And planar graph means, so the graph which is going to be drawn on a plane where the edges does not intersect with each other, so that thing should be considered as a planar graph. And the complement of the graph means it's quite opposite of the edges and vertices of the graph. And subgraph means some part of the vertices of the graph should be considered as a subgraph here. And bipartite graph, so this should be the union of two disjoint independent sets, so that should be considered as party sets of the graph. So the chromatic number is the minimum number that is required to color the vertices along in the graph, such that the two adjacent vertices should have the same color. And map coloring, so this is what is something similar to the graph coloring. And degree means the number of edges incident on the node should be considered as degree here. So in case of directed graph, it should be of two types of degrees, in degree and out degree. So in degree means the number of edges entering the node, and out degree the number of edges leaving the node. The sum of that in degree and out degree considered as the degree of the directed graph. And the path is nothing but a sequence of vertices such that there exists a path or exists an edge from each vertex to its successor. So the cyclic graph means a graph which contains a cycle is nothing but cyclic graph, and which does not contain any kind of cycle, then it should be treated as acyclic graph. So cycle is nothing but a path from vertex to itself, is nothing but a cycle here. And some other paths will be Euclidean path and Hamiltonian path. So in Euclidean path, we have to traverse all the edges in the network only once, whereas Hamiltonian path, we have to visit all the vertices in the network exactly once. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.